Sewage system. Usage/person/day. 170 liters of toilet waste, including flushing water. 130 to 150 liters of washing water. Breakdown of raw sewage. 1 aerobic bacteria, ample oxygen. 2 anaerobic bacteria, depleted oxygen. Aerobic bacteria. 1 biochemical action breaks down the sewage into simple and clear component and carbon dioxide. 2 air, containing 21% oxygen, is bubbled to sustain the aerobic action. 3 not reliant on oxygen for survival. 4 result, black, turgid water gases. 5 gases, toxic flammable. 6 some shore sewage treatment works to produce gas, as fuel. Cargo holding tank. Advantages. 1 low initial cost. 2 ability to meet the zero discharge regulations. 3 no chemical handling required. Disadvantages. 1 need to utilize large tanks. 2 offensive odor problem. 3 corrosion problem in tanks. Vessel. 1 lavatory urinal including flushing water into holding tank. 2 wash basins, showers bath discharge overboard. 3 holding tank. 4 discharge to shore. 5 recycle. 6 aerobic bacteria system. Effluent quality standard. 1 BOD, biochemical oxygen demand. 2 suspended solids content. 3 coliform count. Biochemical oxygen demand. 1 well oxygenated sewage effluent incubated at 20 degrees C. 2 measured amount of oxygen absorbed over 5 days. 3 quantity of oxygen used equates to the amount of further breakdown required. Suspended solid. 1 unsightly. 2 give rise to silting problem. 3 measured by filtering a sample through a pre-weighed pad which is then dried and re-weighed. Coliform count. 1 family of bacteria which live in the human intestine. 2 indicative of the amount of human waste in the particular sewage sample. 3 result, E. coli, expressed per 100 ml. Holding tank. 1 simple holding tank for brief stay in port. 2 large capacity for long stay in port because of the flushing water. 3 require a vent outlet suitably and safely positioned because of gas emissions. 4 vent to have flame trap. 5 corrosion inhibition tank. Biological sewage plant. 1 bubbling air through or agitating the surface. 2 family of bacteria is propagated by the oxygen. 3 digests the sewage. 4 produce innocuous sludge. 5 no toxic or flammable gases. 6 if air supply fails, the bacteria die and plant cannot function correctly until a new bacteria colony is generated. 7 change of flushing liquid. 8 drastic change in temperature. 9 excess use of lavatory cleaning agents. 10 anaerobic bacteria generate gases such as hydrogen sulfide and methane. Biological sewage treatment plant. Aeration compartment. 1 activated sludge imbibes the dissolved oxygen, reduces the influent waste material which comprises carbon, oxygen, hydrogen, nitrogen, and sulfur into carbon dioxide, water and new bacteria cells. 2 CO2 emitted through the vent. 3 water together with the bacteria cells displaced into the clarification compartment. Clarification compartment. 1 mixed fluid settles out and the pure clean water go to the chlorination compartment. 2 activated sludge settled out is returned to the aeration compartment by airlift tube. 3 a skimmer on top to skim off and return surface debris back to the aeration compartment. Chlorination compartment. 1 the pure water dissolves the chlorination tablets, calcium hypochlorite, and flows into the chlorination tank. 2 float switches control the operation of the pump. 3 another float switches for high-level alarm. 4 emergency overflow pipe prevents abnormal overflow of treated water. Chlorine tablets. 1 keep tablets from any combustible materials or chemicals, can cause explosion or fire. 2 keep tablets from fire. 3 emergency remedy. 3.1 wash off with plenty of water. 3.2 if swallowed, drink milk or eat raw eggs or rice gruels. Biological sewage treatment plant. Zero discharge system. 1 normal systems are not designed to produce an effluent suitable for discharge in restricted area. 2 method of reducing retained liquid. 3 no sewage can be discharged in port, required large holding tank. 4 only wastewater from basin and shower are discharged overboard. Zero discharge system. Zero discharge system. 1 recycle the fluid and use for flushing and transport. 2 reduce waste holding tank volume to 2%. 3. Reduction based on 2 liters per person per day as compared to 70 to 114 liters per day for the conventional septic tank. 4. As soon as raw sewage enters the WCS urinals, chemical actions begins as the flushing water contain a sterilizing agent. 5. Flushing water flows into the separation unit onto the perforation belt. The liquid passes through the belt, leaving the solids which be moved and deposited into the collection chamber where it is treated with caustic material. 6. When full, the solid is pumped through a grinder pump to a holding tank. The treated waste is inert and non-corrosive. 7. The liquid flow into the chemical tank where it is treated with chlorine and caustic compound. These remove the color, and sterilize and deodorize the liquid. 8. The treatment tank acts as a reservoir for the flushing fluid.